Hello my dear students, welcome back to NEET World. So today we will be discussing continuation to the last class, that is haloalkanes and haloarenes, where we have completed SN1 SN2 and the next E1 and E2, right? So E1 and E2. So today we will be discussing more about this E2 reaction, then comparison of all these four reactions, okay, and deciding which reaction is taking with particular type of conditions, okay. So what are the conditions favors SN1 over E1 and SN2 over E2. Like this we will compare everything and we will make some clarity on these chemical reactions, okay, right. Let us start our discussion. See, these sessions are equally important for all the students who are preparing for JEE, NEET, EAPCET, okay. See, we have in elimination reactions, we have covered E1 and E2, okay, in the last class. Then next here, what are the properties to be remembered from E1 elimination? So E1, unimolecular elimination reaction here. So it will be favored by what type of solvent? Polar protic solvent that we discussed in the last class. So it is a two-step reaction. So why we are saying it's a unimolecular reaction? Because in the first step, like substrate is there now. So substrate forms some intermediate, like carbocation intermediate is formed. So this carbocation formation step is a rate determining step, RDS step. So from here we will get our final product, okay. So in the carbocation intermediate formation, so how many molecules are involving? Only substrate is involving, not the base. So that's why we are saying it is a unimolecular reaction, okay. And the next one is, how many steps you are seeing? This is rate determining step. The carbocation formation is one step and product formation is a second step. So it's a two-step reaction, okay. So in elimination reaction, in both E1 and E2 reactions, alkenes will be formed as a product. What is a product formed here? Alkene. Let me show you one example again. So here if you write this, here halogen is there, let us say chlorine is there, and like this we have, let me write here one hydrogen. So the alpha carbon, like chlorine attached carbon is called alpha, adjacent carbons are called beta. This is beta and this is also a beta carbon with respect to the chlorine right now. So now what happens is this is beta carbon, this is also beta carbon with respect to this chlorine. Now what happens is beta elimination, alpha beta elimination or 1,2 elimination takes place. 1,2 elimination means what? First of all, elimination of chlorine atom from here. For example, if it is a tertiary carbon, if you consider like this, see there are three groups here. So to this carbon, one alkyl group, second and third alkyl group, this is chloride. So if this chloride goes out, what will be the species formed here? See what happens, tell me. We are going to get methyl group here as it is. So this chlorine going out and we will be getting a positive charge on the carbon. So what we can call it as? We can call it as carbocation, okay. And here if you see there is a hydrogen, okay. And this side I am writing CH2 and one hydrogen over here, like this is as it is. So the formation of carbocation is a rate determining step. So this step is what? Rate determining step. What do we mean by rate determining step? It's the slowest step taking place in the reaction, okay. It means a rate of, how fast or how slow a reaction is proceeding will be given by this rate determining step, okay. Now what happens, see, with respect to this carbocation, we have the adjacent carbons now on this hydrogen. If I remove this hydrogen, now what happens? These electrons can be given to this vacant orbital of this carbon, p vacant orbital. So here also if I remove this proton, yes, we can give like this. So there are two possibilities, either from this side or from this side, because two beta positions are there. From both I can remove a proton. So now what are the possible products here? We have two possible products here. So what are the possible products here we have? There are two possible products, okay. One is from this side. So I'm writing that like this, okay, by removing this proton, this side proton. And if I remove from this side, if I remove from this side or from here, what happens? We'll get a double bond like this. Okay, now out of these two, which is a major, which is minor product, they will ask. Which is major product formed during the reaction, they will ask. How do we answer that? See, it is an internal alkene. Internal alkene means, see, double bonded carbons like this C double bond C is there. So on that, how many alpha hydrogens are there? See, the double bond carbons are there now to the adjacent to this carbon. See, this is adjacent carbon alpha. So to this is also adjacent carbon alpha. So on the same this side also double bond carbons. Here we have methyl. Here also we have methyl. So this can be also considered to be alpha hydrogens. Okay, like the total how many alpha hydrogens are there? Okay, alpha hydrogens, alpha carbons are 4, and each carbon there are 3 hydrogens. So total 12 alpha hydrogens are there. So it means 12 hyperconjugations are taking place with respect to this double bond. Okay, so it means how many times it is stabilizing by hyperconjugation? 12. Okay, by 12 resonating hyperconjugative structures. That's why this internal alkene is more stable. So this is more stable alkene. That's why it is formed as a major. Okay, so out of these two alkenes, which is more stable alkene? This one, internal alkene. This one is called as internal alkene. Why we are calling it as internal? See, if you observe this carbon, the double bond here is at the terminal carbon. On the terminal carbon, like 1, 2, 3, 4, if you number, on the terminal carbon you are seeing a double bond right now. So you can call it as a terminal carbon. So you can call it as terminal alkenes. What you can call? Terminal alkenes. Okay, whereas this one, if you see, the double bond is not on the terminal carbon, it is internal, inside, right now. So you can say this is internal alkene. So internal alkenes are formed as major products in elimination reactions. Okay, is this clear? Why internal alkenes are major? Because internal alkenes are more stabilized by hyperconjugations. Okay, and one more thing here is this internal alkene product is there now, so that is called shades of product or Zs of products. Zs of. So there will be different ways to write this. Sometimes it is, some books it will give us Zs of or shades of. Okay, here I am writing both Zs of product. Okay, whereas this terminal alkene product is there now, this terminal alkene product. Okay, this is called Hoffman product. What you can say? Hoffman product. Okay, so which is major? Shades of products or Hoffman product? Hoffman shades of product is major in the chemical reactions. Why it is major? Because it is more stable. That's it. Okay. Yeah, this is how you need to understand about shades of product and Hoffman product during the reactions. Okay, right. Let me give you few more important points here. See what is happening here. First step is formation of carbocation. So is there any other species involving along with our substrate? No, right? Only substrate is involving in the formation of carbocation. So then next here you can say rate determining step. So in rate determining step only substrate is involving now. So rate of reaction depends only on concentration of this substrate. Okay, that's why we are saying order with respect to this one is 1. So we are saying it as a first order reaction. First order reaction. Now one more thing, if you observe, see this is a carbocation, right? So from here we need to get deprotonated. So for deprotonated we require some base like KOH, alcoholic KOH, like that we need to take. So base is abstracting this proton. So does this in the rate determining step base is involving? No, right? Base is not involved. So it means the rate does not depend on concentration of base. So that's why it is a first order reaction and a unimolecular reaction. Okay, and what is the intermediate formed? Formation of carbocation is a rate determining step. So carbocation is the intermediate. It's a 2-step reaction. What is the reactivity of alkyl halide? 3 degree alkyl halide is more reactive than 2 degree 1 degree. Even same story applicable in case of E2 elimination also same, that is also 3 degree, 2 degree, 1 degree, because respective alkenes formed as a shades of product will be more stable due to their hyperconjugations by the alpha hydrogens. Okay, that's it. Okay, then next E2 elimination. See here what I am writing in E2 elimination. So E2 elimination means, see what I am writing, it is little bit differ from the previous discussion. See here, base will be taking, most generally base will be like alcoholic base, alcoholic KOH, NaOH will be considered here. So alcoholic KOH is taken. Now what happens here is heating condition is required for this, heating condition is required. Now what happens is this base will abstract this alpha beta proton. See, chlorine attached carbon is considered to be alpha, the adjacent carbons are there now, these are beta. So from this beta position OH minus abstract the proton. When it is abstracting, what happens, this sigma bond will becomes this side. Why it happens? Because chloride ion will polarize this bond, and here you will get partial positive charge, partial negative charge in the chloride. So chloride ion is a good leaving group now, it comes out. See, it is going out means electron deficiency is increasing here. So at the same time this OH minus will abstract this proton, therefore the sigma bond which is present here between hydrogen and carbon will be shifts into the vacant orbital of this carbon. Okay, that's it, or sigma star orbital of this carbon. Therefore it will make a bond like this, like this. Okay, is this clear? So now one more thing you need to remember is, see, if this chlorine is above the plane, here the hydrogen which we are removing from here is should be below the plane. Okay, so the elimination is trans elimination here. What elimination it is? Trans group elimination takes place. Group elimination takes place. So this is also called as anti-periplanar elimination take place. Okay, anti-periplanar elimination. It means leaving group and beta proton should be trans to each other. Okay, right, that will be the one of the important step to be remember. Leaving group and beta proton, how it should be? Trans to each other, trans to each other. Okay, and one more thing after this, see, I can remove beta proton from here and also from here. Okay, so if I remove from here, yeah, we will get this type of alkene. But which is major product out of these two? This A or B? A. Why A is major product? Because it is internal alkene. It's a terminal alkene. So internal alkenes are more stable. So that's why it is formed as major. Okay, remember this. So in E2 elimination, so if you see in the rate determining step, what is the rate determining step? See, this is the rate determining step where leaving group is going out, eliminating group going out, simultaneously base is abstracting proton. So now rate of reaction depending on two factors, one is concentration of the substrate as well as concentration of base also. Okay, so in E1 elimination it is independent of base nature, whether it is weak base, strong base, concentration high, low, no matter there, because it is not depending on base concentration in E1 elimination, but here it is depending on base. So if you take stronger base, reaction takes place, abstraction of proton is easy, reaction takes place more easily. So okay, so order with respect to substrate 1, order with respect to base is 1, so total order of this reaction is 2. What is the total order of this reaction? 2. That's why we are calling it as bimolecular elimination reaction. Bimolecular, it is indicated with E2. Okay, now it is a single step or multiple step? It's a single step. Okay, it means we are seeing only transition state, no carbocation formation. So how this transition will be looking like? See, these electrons are coming here now, so you will get a partial double bond character when this group is going out. Okay, that's it. Okay, so the next, whereas E1 elimination favored by polar protic solvent. Which one? E1 elimination. Even SN1 reaction also favored by polar protic, but SN2, E2 reactions are favored by polar aprotic solvents. Polar aprotic solvents favors E2 elimination. Okay, so here rate of reaction depend on concentration of base also now. So we should take here strong base. Strong base favors the E2 elimination. Okay, now reactivity you can check here, it is also tertiary, secondary, primary. Okay, this is same in case of E2 elimination and E1 elimination. But when it comes to SN1 and SN2, what we have studied, SN1 and SN2, here SN1 is favored by 3 degree, 2 degree, 1 degree. Okay, whereas SN2 will be reverse, 1 degree, 2 degree, 3 degree. So it means alkyl halides reactivity is same for SN1 reaction, E1 reaction, E2 reaction. See, like 3, 2, 1 only. Whereas for SN2 it will be difference, like opposite. Okay, so now they will ask For alkyl halides, the reactivity order will be differ for which are the following reaction. They will say SN1 SN2 E1 E2. So for which reaction it is differ? Alkyl halide reactivity is different only for SN2. For E1 E2 and SN1 it is 3 degree alkyl halide, next 2 degree and primary. Okay, this is what you need to be remembered here. Okay, right. And after this let me give you so there are two types of products I told you. One is elimination, that is Sage-Jaffe product, other one is Hoffman. So Sage-Jaffe product is nothing but internal alkene, whereas Hoffman product is what? Terminal alkene. What is this? Terminal alkene. So let me give you when it is forming Sage-Jaffe product, when it is forming Hoffman product. See, mostly it will be forming Sage-Jaffe product only, except there are few conditions. See, if weak leaving group, weak eliminating or leaving group is present on substrate, then Hoffman elimination takes place. So what I am saying, if weak leaving group is present on substrate, then Hoffman elimination takes place, or Hoffman product is formed as major. Okay, so major product is which one? Hoffman product. When it is weak leaving group is present. Okay, or if bulky base is involved, which one? Bulky base is involved, is present, then Hoffman product is formed. Hoffman product formed as major. Okay, these are the two important points to be remembered. Okay, for example, here I am writing, see what makes the difference. Here I am writing chlorine and here I am writing fluorine, and here I am using alcoholic KOH under heating condition. Same condition here also, alcoholic KOH under heating condition. So what makes the difference between reaction 1 and 2? Tell me, what is the difference between 1 and 2? So here we have chlorine, there we have fluorine. Okay, so due to similar sizes, fluorine and chlorine are almost having same sizes because they belongs to same period. So which period they are? Second period elements, carbon, nitrogen, oxygen, fluorine. No? So due to their similar sizes, the bond formed between carbon and fluorine is very strong. Okay, therefore it will not comes out easily. So I can say fluorine is a bad leaving group, it won't comes out easily. So it's a bad leaving group now. So if the substrate is having weak eliminating group, that means bad leaving group, then that gives Hoffman product as a major. So what type of product formed here as major? Hoffman product. Hoffman product means terminal or internal? Terminal. So terminal alkene will be formed as a major. Okay, we have beta protons here and here. So from, but where from I should remove the proton? From this terminal side or internal side. So whenever there is a weak leaving group, it is found to be that Hoffman product is formed as major, that is terminal alkenes are formed as major. So this base abstract the proton from this outside, okay, and gives you a double bond over here. Okay, so this is how terminal alkenes are formed. So Hoffman product I can say. Whereas here if you see, due to the difference between the carbon and chlorine, so chloride ion comes out easily. So now what it will do, the base will abstract a proton from internal side, then that will be giving a more stable alkene like this. Okay, is that clear, both the differences? Right. Yeah, the next one I will be giving you few more questions. Let me take some water. Yeah, tell me where do you have the doubt? I will repeat the same thing if you want. In the chat box someone asking, GKS asking, so please repeat. Yeah, look at this once again what I am explaining. See, there are two types of products possible. Whenever there is a chlorine like this, I can remove beta protons from inside, okay, and from outside. So, but what I am saying is, whenever this group which is leaving group is good leaving group, like chloride ion comes out easily due to the difference between this electronegativity, okay. But if I compare fluorine here, the place of chlorine I am writing fluorine. So now what happens, the carbon fluorine bond like overlapping will be very effective because of similar sizes. So the bond is stronger when you compare with this. So it won't comes out easily as we seen in the case of chloride, okay. So that's way what happens here, base takes a proton from this external like outside, okay, and gives you external like terminal alkene. When it comes to here, yeah, this chlorine chloride ion comes out easily, then base can able to take this proton from inside and you will get a internal alkene, that's it. So Sage-Zaff product is formed, here it is a Hofmann product. So you got to know that whenever there is a weak leaving group, which type of product is formed as major? Hofmann product, okay, that's it. This is what you need to remember there, okay. The next point here is, whenever there is a bulky base, bulky base means what? See here what I am writing. Okay, see, this is the base I am giving you under heating condition, and next one is just I am giving you alcoholic NaOH under heating condition. Now tell me what type of products formed here. This is a question they will mention, okay. Sodium hydroxide or potassium hydroxide will be given here. Now tell me, out of these two, which will give internal alkene, which will give external like terminal alkenes? Where do we get Hofmann product as major? See here, this is a bulky base, right? See how bulky it is, okay. So this bulky base does not enter inside the ring, inside this compound to abstract this proton, because this will be hindered by the methyl groups or other alkyl groups around it, okay. Now what happens, it won't enter inside to abstract this proton, so it is easily take the proton from this terminal side, okay. This is a bulky group now, so just take a proton from the less hindered side, okay. So if it is taking from here, you are going to get this beta alpha, so alpha beta double bond is formed like this. So this is called Hofmann product. What it is? Hofmann is major here, okay. So second application is also done. Now you check for this, when you have alcoholic NaOH. Now what happens, this base is a smaller base, can abstract proton from inside and gives you alkene like this. Got the difference? When small base, smaller strong base is there under heating condition, you get Sage-Zaff product. But if you have bulky base, you will get a Hofmann product. That's it. These are the two terms you need to remember. Okay, yeah. So if you want to check their experimental data, see, more stable alkene, that is internal alkene, Sage-Zaff product is major when your base is small. See, this is a smaller base compared with this. In that case, 79% of Sage-Zaff product we are getting, and just 21% of Hofmann product we are getting, okay. So but if I change this base to the bulky base, what I am saying, bulky, so this bulky base, it is harder to extract remove proton from inside, that's why internal alkene, that is more substituted alkene is formed just 21%, whereas terminal is around 73. So this is 27, that is 73, okay. Do you 73, yeah. Do you see the difference? Whenever it is bulkier base, Hofmann product is formed major. Whenever smaller base, internal product is formed as major, that's it, okay. Now tell me, what will be your product for this? See, methylamine is there, so methylamine will abstract the proton, so we need to get an alkene as a product. But which alkene is major here, tell me? Heating conditions now. Heating means elimination or substitution? From where it should be eliminated? Beta proton should be eliminated. But how many beta protons we have? Just check here. See, with respect to this carbon, yeah, this is beta, these two are also beta, and these two are also beta. So from where it is removed? What I told you, more substituted alkene, more substituted alkene is a major. More substituted alkene should be formed as a major. So now tell me what happens if this base abstract a proton from here, you will get A type of product like this. If it is abstract this proton or this proton, you will get this B type of product. See whether what is happening from here to here. See NH2 is directly attacking on the carbon, bromide is going out. So in the place of bromine, NH2 is coming, like NH2CH3, methylamine is coming. So this is a substitution, this is not a elimination. Okay, this is incorrect. Okay, and this is also incorrect. So we have option B and A. Which is major? Tell me now. Which is more substituted alkene? Yeah. Which is more substituted alkene? B. Yeah. So it has more number of alpha hydrogens, right? So that's why it will be B formed as a major. Okay, is this clear? So this is a Hoffman product. Here it is Sezov product. That's it. Next one is elimination versus substitution. So just remember nature of base or nature of nucleophile. The base taken here should be stronger base. What I am saying? Stronger base favors elimination. What I am saying? Stronger base favors elimination. Okay, just remember this. Okay, so look at here. This is again, we will come back. So strength of a base or a nucleophile. See, conditions are alike for both E1 and E2. See, weak base, poor nucleophile favors E1 or E2. See, in both cases, E1 case we required a base, in SN1 case we required a nucleophile. So, but rate of reaction does not depend on this base in E1 and does not depend on a nucleophile in SN1. Okay, so they depend only, rate of reaction depend only on substrate concentration in rate determining step formation. So if substrate only involving, there is no point of discussing about whether the base is a poor or a stronger, weaker, whether nucleophile is poor, stronger, weaker. Okay, so therefore SN1, SN2 both. Say generally if you take weak base or poor nucleophile, that favors E1 or SN1. Okay, if it is a weak base we will get a E1, if it is a poor nucleophile we will get a SN1, that's it. Okay, now if in case of E2 and SN2, we know rate of reaction depends on both substrate concentration as well as nucleophile concentration. Okay, so in case of substitution, nucleophile. In case of elimination, you should say base. Okay, so in both case rate is dependent on this nucleophile and base only now. So what do we mean by this? Yeah, so if you take stronger base, rate of reaction will be more easy, rate of elimination is more easy. So stronger base or stronger nucleophile favors E2 or SN2. Okay, remember this point also. The next weak base. See this point in the last class when I am discussing about E1 elimination, I told you that high temperatures and low temperatures, see general temperatures, let us say. Okay, high temperatures favors elimination or reaction. What they will favor? Elimination. Okay, at normal temperature substitution takes place, but high temperatures favors elimination, because elimination reaction is an endothermic reaction. Which reaction it is? Endothermic reaction. So for endothermic reaction, forward is favored by higher temperature. What I am saying, for endothermic reaction, forward step is favored by higher temperature. For endothermic reaction we required higher temperature. So in presence of high temperatures, always indicate that the reaction mechanism will be following elimination rather than the substitution. So if you might be having confusion between substitution and elimination. So if you are taking high temperature, which one is favored? Elimination. Normal temperature, substitution. So look at this. See here it is mentioned delta heat. So it means high temperatures now. So high temperatures means elimination. So now this is a secondary alkyl bromide is taken. Okay, so in aqueous, again effect of solvent, aqueous medium favors aqueous, polar protic aqueous medium favors substitution reaction, okay, whereas alkaline, like alcoholic medium, like alcoholic KOH, like that we will be taking, so that will favors elimination. Alcoholic solvent favors elimination, okay. Normal aqueous solvent favors substitution. See, SN1 reaction here, taking chlorine goes out, OH minus enters in, so you will get a propanol, okay. When it comes to this elimination reaction, remember alkene is formed, so this bromide ion goes out, carbocation formed, then beta proton is eliminated, we will get a double bond like this, so propene is formed, okay, right. Next one here, stronger base. So what we know, stronger the base or stronger the nucleophile, there will be favor. If it's stronger base, favors E2. If it is a stronger nucleophile, favors SN2. Okay. So now here you can see OH minus is there, so that will attacks here, bromide ion comes. So this will be the product. Okay. Ethoxide ion. So this is stronger base. Alkoxide ions are stronger base. So that will abstract this. This proton will be removed, and from here proton, this bromide ion is removed. From here proton is removed. Then we will get a propene like this. Okay. See here OH minus is a strong nucleophile, whereas ethoxide ion ETO minus is a strong base. So OH minus is what? A strong nucleophile here, whereas ethoxide ions are stronger bases. So the reaction with OH minus follows substitution, okay, whereas with alkoxide ion follows elimination. So alkoxide ions are stronger bases here, you can remember. So in case of alkoxide ion, you can expect it to be elimination reaction. What is that? Elimination. Alkoxide ion under heating condition. Okay. So what we discussed, rate of reaction increases. If it is an elimination reaction, rate of elimination reaction increases more as compared to the rate of substitution upon increasing the temperature. So with increase in temperature, what happens to the rate of reaction? Increases. Okay. So after this, so what is the effect of temperature? See, elimination reactions requires higher temperature than substitution. So if temperature increases, rate of both substitution and elimination increases, but elimination reactions favors more compared to the substitution at a higher temperatures. Okay. See, solvent effect, what I told you, aqueous KOH that favors substitution, whereas alcoholic KOH favors elimination. Why? Because alcoholic KOH, like alcohol is there, ROH is there. Now here KOH I am adding. So KOH react with this alcohol and generates a alkoxide ion. So this alkoxide ion is a stronger base. Okay, it's a stronger base. So that's why it is favoring elimination. Okay, favors elimination. Okay, that's it. Look at this, what makes the difference between them? See, aqueous is there. When it comes to here, it is alcohol is there. So aqueous means what happens? A substitution. Okay, it's a primary alkyl bromide. Na? So primary alkyl bromide, we know first of all aqueous means substitution. If it is a primary alcohol, primary alkyl halide, favored by SN2 mechanism. Okay, it is favored by SN2 mechanism, and in the place of bromide ion we will get OH, nucleophilic substitution is done. Okay, so when it comes to alcoholic medium, alcoholic KOH, and temperature is relatively higher, you can see. Okay, So this will be favored by E2 elimination. Which one? E2. Okay, because this is a primary now, so it won't form a stable carbocation. That's why it is not following either E1 or SN1. Okay, so they are following SN2 in this case. Here it is E2. Okay. So now once again reactivity of alkyl halide. So I already told you SN1 E1 E2 follows 3 degree 3 degree 3 degree 2 2 2 2 2 1 1 1. Okay. Only SN2 is a differ. Only SN2 is a differ. That's it. This is important point to be remembered. Okay. So now tell me what are the products we have seen. So if it is a primary alkyl halide, it will follows SN2 mechanism unless there is a steric hindrance in the alkyl halide or nucleophile, otherwise E2 will be favored. So it depends on base also, anyways SN2 and E2. Okay. So when it is a primary, it cannot undergo either SN1 or E1. If it is a primary means what you can say, SN2 or E2. Okay. When it is secondary, so both SN2, E2 favors. Now you need to look for the solvent effect. What you need to look for? The solvent effect as well as a basic nature. I mean strong base or weak base, those things we need to consider here. Okay. See, stronger bases, stronger and bulkier bases favors elimination over substitution. Okay. So both substitution, elimination, both of them are possible here. So if I have tertiary alkyl halides, only elimination takes place. Okay, between E2, between SN2 and E2 if I compare, only elimination. If I want to compare between E1 and SN1, yeah, both are possible, because in both cases, tertiary means both cases we will be having a carbocation formation now. Yes. So again you need to look for the solvent and whether given compound is base or nucleophile. Okay. Now tell me which are the following mechanism involved in the given reaction. Tell me what happens here. Yeah, heating condition is taking place. Okay. And what about this solvent mentioned here? Water. So water is a polar protic solvent. What I am saying, polar protic. So polar protic solvents favors E1 elimination over E2. So what they will favors? E1 elimination over E2. See, from the substrate to react product, if you see, it is elimination or substitution. See, substitution means this should go into that place, we should get some other nucleophile, but it is not happening. It is removing chlorine from here and hydrogen from here. It means elimination. Okay. So elimination is favored. Okay. It means not A, not B. So out of these two we need to say, but how can we decide which one it is? So heating condition means elimination. Next, what about this solvent used here? It's a polar protic. Water is a polar protic. So polar protic solvents favors E1, not this E2. Polar aprotic. For example, acetone is mentioned, means you can say this reaction is following E2 mechanism. But here water, which is a polar protic, so it is a E1. So option C. Okay. The next here, what are the factors stabilizing, factors affecting the stability of carbocation? So first you need to check for the aromatic nature. The next, equivalent resonance if present, then that will be also stable. The next you need to check for the resonance, hyperconjugation, and least is for inductive. Okay, this is important again. Okay. So just tell me which alcohol derivative is most reactive for SN2 reaction. Tell me which alcohol derivative is most reactive towards SN2 reaction. Yeah. So how do you get this SN2? See here, all of them has R group. Along with some R group, there is some groups here. These groups are there. Okay. So now which groups comes out easily? Which groups comes out easily? There is some group, something like X, I am generalizing it as X. Okay. So if I remove this X, so whatever the X minus comes out, that should be more stable. Okay. So in this case here CF3 is there now, and along with that CF3, just see here double bond O, here also double bond O is there. So if I remove this compound from here, you will get R which alcohol derivative. Okay, so R and some nucleophile comes in, and what is the part coming out of here? CF3 S double bond O minus. So this can be stabilized by resonating effect like this. So whenever we have resonance, that will be more stabilized. Okay, so here between two same atoms now, so we can say it as a equivalent resonance. Whenever the resonance is taking place between two same atoms, then you can say it as a equivalent resonance. So equivalent resonance is more stable, okay, or more effective compared to the normal non-equivalent resonance. Okay, so equivalent resonance can happen here, here and here, but along with that we have a stronger withdrawing group that will hold the negative charge effectively. That's why third one is the third compound is most reactive towards substitution when we compare with the other options. That's it. This is how you need to answer. Okay, right. Let me give you one more question here. Which are the following is most reactive towards SN2 reaction? Tell me, in SN2 reaction, which compound is more reactive? Now I told you during our discussion in the first session on this SN1 and SN2, I told you electron withdrawing group containing compounds favors SN2 mechanism, or I can say SN2 rate of SN2 reaction increased by electron withdrawing groups. Okay, so in which group, which halide, like all of them are benzylic chlorides only, benzylic chloride. Okay, so but which one is having electron withdrawing group? Tell me, where do we have electron withdrawing group? See, this is a methyl group, electron releasing group it is. Okay, so here we have a weakly ring activating. Okay, so but here if you see, this is a nitro group. It's a strong electron withdrawing group. If it is a strong electron withdrawing group, what happens? That will stabilizes whatever the electron density getting here. It means electron withdrawing groups increases rate of SN2, I told you. Okay, so which is more reactive here? It's the fourth option, because of presence of strong electron withdrawing group. Okay, that's it. Okay, so if I ask which is least reactive here, if electron withdrawing group is present, rate of that SN2 reaction increases. Okay, but if I have electron releasing group, that will decreases the rate of SN2 reaction. So which is the least reactive now? The first one is the least reactive, as it is having electron releasing group. Okay, so just remember two statements. If electron withdrawing groups that increases SN2 reaction, SN2 rate increased by electron withdrawing group. Okay, and SN1 reaction rate increased by electron releasing groups. These are the two statements can be your savior terms or things during the exam. Okay, remember. Now what is happening here? See, stereochemistry point of discussion here we have. So 2-bromobutane is allowed to react with aqueous KOH. Identify the product formed in the reaction. See what they are saying, R2-bromobutane is given. So R2-bromobutane, see, R2-bromobutane. So if I say R2-bromobutane, this is bromo, okay, butane, allowed to react with aqueous KOH. Identify the product formed in the reaction. So tell me how we can answer this question. So aqueous KOH it is. So tell me how can we do this? See here, R means I told you to write this thing, stereochemistry. So R2-bromobutane means, let us say this is above the plane, this is above the plane, bromine and hydrogen below the plane. Now just check how the configuration 1, 2, 3, 4, how it is going plane, so clockwise. So it is R configuration, yeah, this is R2 bromobutane. So 2-bromobutane, that is R configuration. okay, allowed to react with aqueous KOH. See, aqueous, this is a secondary carbon, right? That is a secondary carbon. So it has both possibilities to undergo SN1 as well as SN2. Okay, so SN1 and SN2. Now what I am saying here is, since it is an aqueous medium with KOH, so now what happens here? It will be undergoing SN2, let us say. Now what happens here? So this will be attacking from above the plane, so that you will be getting OH, and here hydrogen above the plane I can write. Okay, you will get this kind of product, but configuration is becoming S here. So what happened to the configuration? Configuration is becoming opposite. So what you can say opposite configurations means? It is inversion of configuration. So inversion of configuration takes place in which case it is? In SN2 reaction. Okay, so where do we have a SN2 reaction, inversion configuration? It should become S configuration. If it is R, product should be S. Okay, so just try to identify these configurations here. So 1, 2, 3, how it is? Clockwise direction, okay, it should be R, but least priority group should be on like horizontal line, then configuration becomes opposite. So this is S. Okay, so like this. So R becoming S now. Yes, this is our SN2 product. Okay, so this is our SN2 product during the reaction. Okay, so this is how you need to identify what type of product. See, in SN1 reaction what happens? It is racemic mixture is giving. Okay, partial racemization is taking place. But in case of SN2, inversion of configuration. So S configuration product gives S configuration reactant gives R configuration product, R configuration reactant substrate gives S configuration product. Like that you need to remember. Okay, the next, identify this. The major product in the given reaction below is, what happens here? The major product, see, heating condition, alkalic elimination, right? So after that you tell me from where I need to remove proton. So tell me what happens here. So it will abstract the proton, but from where? From where it will abstract? But from where it will abstract? Tell me. The major product of the reaction given below is, so from where it can, see, I can remove a beta proton from here or from here, but which is major? Internal alkenes are major. So because if I remove from here, you will get a conjugate to alkene, like this. Okay, so if this is a conjugate to alkene formed, then this will be in conjugation with the ring pi electrons, so it is considered to be major. Okay, like this. So where do we have such product here? Yeah, observe this first option, that will be your answer. Okay, right. The next one here is, yeah, so there is some X compound, upon treating with alcoholic KOH, the heating condition giving you this product as major. So what is our X in the 4 options? See, what I told you, when it is undergoing elimination reactions, it should have the eliminating proton, eliminating group, and beta proton should be trans to each other. How they should be? Trans to each other. Okay, so H plus and X minus, like bromide ion here, should be trans to each other. So it means here, if you observe, the bromine is above the plane now. See, remember this thing. So these two groups are cis are trans to each other. See, this is above the plane, this is below the plane, below the plane. So if the configurations are differ, then these two can be related as a trans. How they related? Trans. It means proton here will be, how it will be? Below, already below the plane is there now. This will be now above the plane. So now how this proton is related to this bromine? cis or trans? Same plane now, so cis. Okay, so same plane is a cis. Okay, so cis elimination won't take place. It should be trans. Then only we will get a double bond with respect to this methyl group. Okay, with respect to that methyl group. So this is not our option. Okay, now compare the second option. See what we have. The bromine is above the plane, bromine, and methyl group is also above the plane. So if methyl group is above, these two related as a cis to each other. But what about our this hydrogen here below the plane? No? So bromine and hydrogen, how they are placed? Trans to each other. Since they are trans, yes, trans configuration only there, that both beta proton and the eliminating group should be trans to each other. Yes, then only we will get a product like this. So we will get a double bond over here and methyl group over here. That's it. This is your answer. So which option is perfectly correct here? Which option is correct? See, these are trans to each other now. So our option B is your answer for the question. Okay, right. The next, which of the following gives fastest reaction with alcoholic KOH? Tell me, which of these four options gives you fastest reaction with alcoholic KOH? Okay, it means we need to treat them with alcoholic KOH. What with we need to treat? Alcoholic KOH. Now what happens if I treat this with alcoholic KOH? See, this is alpha carbon, this is beta. From here we can remove proton. So if this proton and this bromide comes out, you are going to get a benzene ring like this. See, benzene is aromatic compound now, so it will be formed very fast. Okay, but if you talk about this first example, here you have proton, you can remove like this, so you will get a conjugated system like this. Yeah, but it is a non-aromatic. Conjugative system is there, non-aromatic. From here if you remove, like this we will get. Okay, and this bromine won't comes out because it is in conjugation. Okay, so if I say what is the perfect answer for this, which is giving you aromatic compound here, second option, no? So that will be fastest reaction. Now if I ask you order of the reaction, first one is 2, 1. Why 1? Because it is giving a conjugative system. Okay, yeah, 2, 1. After this 3, and vinyl halides won't involve, so it is least, that is a 4 here. So it is least. Okay, this is how you need to answer. Yeah, so I told you about PCl5. So PCl5 follows SN2 mechanism. Which mechanism it follows? SN2. If it is following SN2 mechanism, now PCl5 following SN2. If the configuration at this carbon is R, then product will be inversion. It will be giving S. If here configuration is S, product will be having R. Like this we will be seeing the configurations. Okay. Now tell me, this like that we will be observing the change. Okay. Now tell me, what about the configurations over here? So this is OH1, ethyl 2, and this is methyl 3. How they related? How they related? Clockwise. Clockwise means R, but least priority group is on horizontal line, so it becomes S. So this is S configuration. So product will be R. So it should be in the place of OH we are keeping chlorine. So we will get R 2 chlorobutane. That's it. Where do we have that option? R2 chlorobutane. So option 2 is your answer for the question. Okay, right. The next one here, see what they are saying, NaOH DMSO. Okay, so DMSO is a polar aprotic solvent. What I am saying, this is a polar aprotic solvent. Polar aprotic solvent. So polar aprotic solvent favors SN2 mechanism. Which mechanism? SN2. So out of these 4 options, tell me which is your correct answer. See where the reaction takes place. See, NaOH is there. There is no heating condition, means it is following substitution, not elimination. So but where the elimination takes place, where the substitution takes place, see here bromide ion, bromine is there now, so it will goes out, to that we will get OH. But which mechanism it is following? SN2. So configuration, what happens if there is chiral center? Inversion. R becomes S, S becomes R. So it means this side we have bromine now, like opposite side it will becomes OH. So you can write that as CH3 at the down, this D and H remain same, here OH, H, that's it. So where do we have such option? 2. So that will be your answer. Okay, right. Is this clear what we are discussing? That's it. Okay. Now tell me, SN2 reaction mechanism proceeds through intervention of what? Is there any transition state or carbocation formation? What is taking place? Transition state, that's it. Okay. In SN2 reaction, if we double the concentration of reactant and nucleophile, what happens to rate of reaction? See, rate of reaction depends on concentration of both substrate as well as nucleophile concentration right now. So if we are increasing concentration of substrate 2 times, okay, doubling means 2 times. So substrate concentration 2 times and nucleophile concentration also 2 times. Now what happens to rate? 2 2s are 4. So rate increases by 4 times. How many times? 4 times. So we have 4 here. So option 2 will be your answer. Okay. Next. So these questions already discussed in the last session also. Right. Now we will be discussing about reactions of haloarenes. What we are discussing? Chemical reactions of haloarenes. So what are the chemical reactions shown by haloarenes? Tell me. See, haloarenes means an aromatic ring, like benzene ring if you take, on that we will be having one halogen like this. Okay. Now haloarene, if you observe, the lone pair electrons of halogen will be in conjugation with the ring electrons like this. Okay. If you look normally, it will be looking like a single bond right now, but due to the conjugation there it has slight double bond character like this, partial double bond character like this. Okay. Partial double bond character between carbon and halogen. So due to this reason, halogen ion, halide ion cannot be removed easily. So it won't comes out easily. Therefore, aryl halides are very less reactive towards substitution. So aryl halides are very less reactive towards substitution reaction, nucleophilic substitution reaction. But they will show the chemical substitution reactions at a high condition. It means at a vigorous, like high temperature, pressure conditions, they will undergo substitution reaction. They will undergo substitution. Just read this. We know that vinyl halides, aryl halides are extremely less reactive towards nucleophilic substitution reaction. Why? Because they have a strong bond formation due to the conjugation between carbon and this halogen. Due to that reason, these are very less reactive towards substitution. Okay. So because if you remove this halide ion from them, again one more thing, in case if you wanted to do substitution, like removing halide ion from here, what you are going to get? You are going to get a phenyl ring with a positive charge. So this is unstable aryl carbocation is formed. Okay. And pi electron cloud of haloarene is in conjugation. That is what? The partial double bond character of CX. So due to this reason, it is very less reactive and extremely less reactive we have mentioned here. Okay. Right. This is what the point you need to remember. So now the substitution reactions, I mean what are the possible reactions in haloarenes we will be discussing. So, okay, the first one is a nucleophilic aromatic substitution, next one is electrophilic aromatic substitution, and the next reaction with the method. Okay, now as of now I will be explaining this nucleophilic aromatic substitution reaction. It is important. Okay, right. So now what happens here is, in nucleophilic substitution reaction, nucleophilic aromatic substitution reactions, let us say there is a chlorine here. Okay, so now what we are doing is, we are taking one nucleophile. Okay, so here we have one halogen. So in the place of halogen, our nucleophile will comes. Okay, it means nucleophile will be taking the place of halogen like this. So now what makes the difference from here to there? Chlorine is substituted by nucleophile, but this transformation require high temperatures. What they require? High temperature or high pressures both together required, because here I told you chlorine is in conjugation with the ring pi electrons. Okay. Now how can we fast up this reaction? Yes, using high temperature conditions. What we require to use here? High temperature. Not only high temperature, see, I will be telling you one more thing. See, if I insert any electron withdrawing groups here, what do we mean by electron withdrawing groups? It will withdraw electrons towards themselves. So if it is withdrawing electrons towards themselves, what is the charge created in the ring? Tell me. Positive charge or negative charge? Positive charge. So where it will be created? With respect to electron withdrawing group, either orthos or at this para position. Okay. So now what happens is, this chlorine is there. Chlorine is electronegative and this electron withdrawing group is there. So this electron withdrawing group withdraw the electrons this side like this, and chlorine is electronegative, it won't give its electrons effectively. So when it is taken towards this electron withdrawing group, we will get a positive charge over here. So there this nucleophile will attack. Okay. So when it is attacking, what happens there? You will be seeing chlorine nucleophile electron withdrawing group and like this. Okay, like this you will be seeing. Okay. So the complex formed here is called as a Mesenheimer complex. So what is the complex name? Mesenheimer complex. How this Mesenheimer complex is stabilized? Yeah. So these pi electrons are there, na? That using that it will be stabilized. Now I will be writing direct product here anyways. See, now this compound, this whatever the transition or Mesenheimer complex we have got here, this is not a aromatic species. Initially it is aromatic, here it is becoming non-aromatic because presence of this sp3 carbon. Okay. Now what happens? Electron withdrawing group, whatever the pi electrons it is taken, gives back. So when it is giving back, the good leaving group here is halide ion, chloride ion goes out, okay, along with the bond. So now what is happening? Yeah, we are going to get electron withdrawing group here and nucleophile over here. So this is your final product form. Now what are the factors you have seen? Whenever there is electron withdrawing group on this benzene ring, haloarenes, there increases rate of substitution. So rate of substitution is increased by electron withdrawing group. More the electron withdrawing group, more easier the nucleophilic substitution. Okay. And high temperatures also favors, increase in temperature also favors substitution reaction. So here I have an experimental order. See, there is one nitro group, electron withdrawing group, one chlorine. So what is the transformation from here to here you are seeing? So reaction is taking place at 443 Kelvin. Now if you see, there is two nitro groups, it means two electron withdrawing groups is there in this case. Reaction is taking place only at it means temperature lowered or decreased or increased, lowered. So even at lower temperature also taking the reaction here, but what we know, reaction requires higher temperature. Here even lower temperature, even if you decrease the temperature also reaction is taking place. What is the reason behind this? The reason is we have two electron withdrawing groups here. So more the electron withdrawing groups, more easier is the substitution reaction. See, if you observe this third example, there are three electron withdrawing groups. So just warming it is required, just you need to warm it. Okay. So treat this with water, see, not even NaOH, it is just a water here. Okay. Now take this trinitrochlorine and warm it with the water. Okay. Then you will get your product. Okay. So it means where more the number of electron withdrawing groups are there, reactivity in that compound will be easy. I mean reactivity is more, that is substitution is easier. Okay. So it means if they ask like 1, 2, 3, these are the three compounds they will give in the exam. Which of the following readily reacts, which of the following readily reacts in aromatic nucleophilic substitution reaction, they will ask. Tell me. Out of these three substrates, which is more reactive towards aromatic nucleophilic substitution, they will ask. So 3, 1 is more, next 3, 2, 1, that's it. So it depending on what factor you are saying, number of electron withdrawing groups we have. Okay, that's it. The next here, yeah, we will come back to this electron withdrawing. So just look at here, the compound that react fastest with sodium methoxide. Tell me which compound will be reactive readily with sodium methoxide. So sodium methoxide is nothing but a nucleophile here. O minus sodium, Na plus. Yeah, like this. So this is a substrate. So tell me now, what happens here? Tell me. So this is a nucleophile now. So what type of groups we required on the benzene ring, haloarine ring? Electron withdrawing groups. So more the electron withdrawing group, more easier the substitution. So where do we have more number of electron withdrawing groups? See here you have 2 nitro groups. So the fastest reaction is in 1. Okay. And if I ask you what is the order of the reactivity for these 4 options? So between 4 or 2, how do you decide? See, para position nitro group having mesomeric effect, minus M effect. Meta position there is no minus M effect. So there is just a inductive effect. So inductive effect is less dominating. So mesomeric effect is highly dominating. So 1, 2, 4, 3. That's it. This is the reactivity order. Okay. Fastest means first option. Okay. Is this clear concept? Yeah. The next one is here. Yeah, we will come back to this later. This is also. Tell me here, this is a JEE mains question, but yeah, based on our discussion you can easily answer. The correct order of the following compounds showing tendency towards nucleophilic substitution is increasing tendency, which is more having. So more the number of electron withdrawing groups. So 4, 3, 2, 1. So where do we have 4, 3, increasing order man, which is more reactive 4. So 4, 3, 2, 1. So 4th option. Okay. Next. Yeah, we will discuss about this again because few more things to study there. Yeah, but one more example I wanted to add here. See, I am writing here fluorine with nitro group, and one more here is chlorine here with nitro group, and here bromine with nitro group. So rate of nucleophilic, aromatic nucleophilic substitution reaction, which is more easily following, which is more easily participating in aromatic nucleophilic substitution out of these 3. They will ask like this. What makes the difference? Everything is same except these halogens. Okay. So now you need to write your answer with respect to these halogens. Okay. So what we know, a nucleophile will attacks at the positive center and a carbon which is having more electron deficiency, So when we will be having more electron deficiency, see, nitro group's impact is same all the case, but which is more electronegative atom here? Fluorine is more electronegative. So that will also withdraws electrons towards themselves, creates more positive charge here now. That means chloride like nucleophile attack is easy in which case? In this fluorine case. So that's why 1 is more reactive, then 2, then 3. So this is how you need to finalize your order. So these are the applications and questions related to aromatic nucleophilic substitution reactions. Okay. So now if you have any doubts, you please mention in the comment box for online students, and for offline student, if you have any doubts, you can also ask me here itself. Everything is clear? Right. So practice more number of questions, then it will become more easier. Okay. That's it. So, right. Yeah guys, if there is no doubt, we will wind up this session. If you have any doubts, please mention in the chat box, and if you are new to this channel, just click on the follow button. We will meet in the next class. Thanks for watching. Thank you.